Good morning, everybody, and once again, welcome back to the channel. In today's video, I basically want to talk about a single table design versus multiple table design. What I mean by that is when you're processing data for a lot of tenants, right? For example, tenant A, tenant B, tenant C, and so on, right? Now, you have a very important choice to make. The choice basically is whether you go for a single table design, meaning you have a huge giant table and which is partitioned by tenant, right, tenant ID or whatever tenant name, right, or you basically go for a separate iceberg table for each particular tenant. Now they both have their pros and cons, right? So in this particular blog that I wrote, I have essentially listed out all the pros and cons, right? What I do want to talk about is the data ingestion method, right? So now, of course, you will ingest the data using Spark, right, into this particular iceberg table, right? I want to just give you a high level idea, right? So let's talk about this. Okay. Hopefully you guys see my screen, right? Let me adjust my screen window. Okay. So let's say you have S3, right? And inside S3, raw folders, right? You have tenant A up to tenant 10 and then Parquet files, right? Now you want to process this particular data using Spark, right? Now, how do you approach this, right? Now, I will show you a couple of methods here. Again, this one is going to be for separate table for each particular tenant. So let me talk about that. Again, I'm showing you block diagram, but again, as we progress in the video, in the upcoming videos, I'll show you the actual full implementation code. Because let me see. I actually, as you can see, I have tested it on my personal S3 account, right? So let's talk about that. So the first method, the most easiest, naive way to solve a problem, right? Let me see if I can collapse this side window over here. Okay. The most naive way is, okay, read all the tenant in Spark data frame. So whatever tenant you have, read all the tenant as a Spark data frame, giant data frame, right? Then basically you invoke cache or df.cache on that, right? Then what you say is, hey, out of the data frame, give me all the unique tenant ID which is there in the Spark data frame. Then you write a for loop. Then you say, hey, for each tenant in tenants, right? Then for each particular tenant, you have to get the Spark data frame. So you will do a filter operation on the big data frame that you have on the top, right? And you say, hey, give me data for that particular tenant. You get the data, of course, then you create an iceberg table and then you do a merge into and the process repeats for all the tenants, right? Again, this approach is easier, only one job, but again, there are cons to it, right? If any one of them breaks, your entire system goes like boom. So anyway, so of course, this is easier to implement, right? Also, uh, if there are like, if a particular tenant is, pushing in lot of amount of data, right? That it could lead to like a skewness of data, right? When you're reading it in Spark. So again, there are Spark configuration which can take care of that. But again, we are going very simple, bare more minimum. Okay, this is the simplest approach, right? Now, what is the next approach that we have? Of course, in this you can thread it, right? So the for loop part, right? So for each tenant, you're repeating certain components, right? So that you can easily thread it, right? That's completely possible. Okay. What's the method two? Okay, method two is, okay, you'll say list all the top directory of the tenant. So basically you'll get tenant A, tenant B, tenant C, right? Basically an array of tenants. Now what you want to do is basically bucket these tenant, use a hash function and bucket this tenant into low, medium and high. Again, you can have a separate bucket or based on your business logic, right? Low, medium, high, simple, right? Low meaning the tenant that require low resources. High meaning the tenant that require extreme lot of resources, right? So then what you can do is for each bucket in buckets, right? So bucket one might have tenant A, tenant B, tenant C. Again, it's going to run a Spark job and for each bucket, there will be a separate Spark job, right? A bucket can have multiple tenants inside it, right? As you can see. So, and then of course, once the Spark job starts, then again, read all the data for that particular bucket and tenants, and then we'll repeat the process, right? Cache data frame, get unique tenants for that particular bucket within that bucket, right? And then process that data, right? So in this approach, what you did is basically, instead of reading all the tenants in a Spark data frame object, right? You are using bucket and hashing function to distribute the tenant among respective buckets, and then each Spark job for the each Spark job for the bucket, right? Bucket 1, bucket 2, bucket 3, again depending upon how you want to name and label it again, right? So basically what we are doing here is we are breaking the tenant by bucketing and allocating higher resources for larger tenant, right? That's the second option that I have. The third method I have over here is, okay, list the unique tenants, right? So basically you'll say, tenant A, tenant B, tenant C up to tenant N, right? And then for each tenant, right, launch a Spark job. So each Spark job is processing data for a respective tenant. That's also a viable option, right? So that is also doable. And then the third method is, well, you approach things a slightly differently. So you have, instead of having multiple iceberg tables, you can have one iceberg table which is partitioned by tenant, right? So in this approach, you'll say, hey, okay, read all the data, read all the tenants as a Spark data frame. You repartition in Spark by tenants, and then basically, you're gonna do your merge into command, and then your iceberg table here is partitioned by tenant ID, right? So single iceberg table partitioned by tenant, and then you are exposing. I repeat, the way you will expose it is using views, right? So expose each partition as a view to the client, right? So that's another option again. So again, there are other options as well, but I just wanted to cover in brief about 4 options here, right? So for example, when you have multiple tenants and you want to process data, you could follow either one of the approaches, right? Again, each has its pros and cons, right? So basically, if you come to this particular blog, I have listed, give me a second. Yeah, sorry about that. So I've listed, all the pros. For example, a single table, right? If you decide to have a single table partition by tenant, right? Simpler to maintain, efficient storage, easy to scale, simpler job design, fewer services to manage. Cons is data access control could be a problem. Risk of data contention could be a problem, right? Slower performance for a specific tenant, that could also be a problem, right? But versus if you go for a separate table, right? Isolated data, independent scaling, custom schema for tenants, right? No data contention, right? Cons are complex management, right? You'll have to have all different jobs. Either you have one job which is writing into multiple tables, or you have separate job, or you are using a bucketing approach, right? Increase overhead, job complexity, right? So which one to choose and when to choose, right? So I have listed this out, right? So I would encourage you to read a little bit more about that. In the upcoming video, what I want to do is, see, I want to give, any company you go and work for, right? They would have all these use cases. This is a common pattern, right? Multiple tenant data is there, and you want to process it using Spark or any other engine, right? So in the upcoming videos, I will actually show you the code implementation part. I will actually, let me actually go to my draw.io. I will go with method 1 first. I'll show you the most easiest approach. I'll actually write the entire Spark code. Then I'll show you the method 2. Method 3, I think I have to label this as method 3, right? And then the method 4, right? So that way you guys can learn and enjoy. It's going to be a fun project, right? You can do it locally, and it will again teach you a lot of stuff, right? So I'll go with the method 1, then I'll show you the threading, then we'll monitor the performance, then we'll do the method 2, method 3, method 4. We'll compare all of that, and that's about it. So that's all I have for the video. I hope you have excited and you enjoyed the insight, right, on how to process data when you have multiple tenants, right, using Spark. Let me know your questions in the comment section below, and I'll be more than happy to answer them. With that being said, keep smiling, keep programming, and I will see you in the upcoming lab section.